There were many unknowns about the universe when scientists conceived and developed the Hubble Space Telescope, the most innovative astronomical observatory of its day. One of these big unknowables was the existence of stars and galaxies a few 100 million years after the Big Bang, according to Mark Makarin, Senior Advisor for Science and Exploration at the European Space Agency, or ESA. Even if they were aware of these early stars and galaxies, they lacked the equipment to make Hubble see them. Welcome to Tech United, a place where we bring tech and people closer together. Are you excited enough? What are you waiting for? Subscribe, like, share, and smash the notification bell to get the latest news and updates on Tesla, Apple, SpaceX, and more. Alright then, let's get started. The James Webb Space Telescope was intended to transform astronomy. Many of its most groundbreaking findings may come from currently unclear regions in 10 years. What makes Hubble and Webb so intriguing is that they are both general-purpose observatories, added Kimble. They have certain specific core research aims, but they have a broad range of capabilities that allow them to produce discoveries that aren't in the areas for which you intended the telescopes. If you look at Hubble's greatest hits, half of them were for things they knew they were building it for, and the other half were for things no one knew about, like dark energy and exoplanet research. We are hoping the same is valid with Webb. For decades ahead, it will be young astronomers like Jones, who was only a child when the James Webb Space Telescope was planned, who will be unraveling those vast unknowns. The James Webb Space Telescope will revolutionize our understanding of the universe, Jones stated, and it's because people thought about it while I was in primary school that individuals like me can now make use of it at this level of our lives. The instruments used by the James Webb Space Telescope are as follows. NIRCam, Near Infrared Camera. NIRCam will be critical in achieving Webb's primary goal of detecting light from the very first stars and galaxies. It's more than simply an infrared camera, it's also equipped with some additional tools recognized as coronagraphs. The coronagraphs would allow scientists to filter out the light of a star and observe what's going on around it, making them ideal for detecting exoplanets orbiting stars. NIRSpec, Near Infrared Spectrograph. The primary tool for deciphering the chemistry of the universe is NIRSpec. It will divide the light from the distant galaxy into spectra, exposing the detected object's attributes like temperature, mass, and chemical composition. Considering some of these entities are incredibly far and emit highly dim light, the James Webb Space Telescope, despite its massive mirror, will have to look at them for hundreds of hours. NIRSpec would observe 100 such distant galaxies simultaneously, making those observations more efficient. It effectively allows you to open little doors and let light through from one galaxy while blocking out all light from everything else, Makarin explained. However, you can, for example, open 100 doors at once. That's highly complex, and it's never been flown in space before. The Mid-Infrared Instrument, MIRI. MIRI is a camera as well as a spectrograph combined. Still, unlike the earlier ones, it recognizes in the longer wavelengths of the mid-infrared part of the electromagnetic spectrum, making it a go-to instrument for anyone interested in studying everything from comets and asteroids on the periphery of the solar system to newly born stars and faraway galaxies. MIRI's photographs will be the most similar to those that made the Hubble Space Telescope famous. FGS/NIRI-SS, Fine Guidance Sensor/Near Infrared Imager and Slitless Spectrograph. FGS/NIRI-SS would also aid in the identification of the first light and the detection of exoplanets, and the analysis of their chemistry. Rescue missions are unfeasible with the James Webb Space Telescope, hence, no failures are permitted. The James Webb Space Telescope is a pioneer, and with prototypes, anything is certain to go wrong, said Mark Makarin, Senior Advisor for Science and Exploration at the European Space Agency, ESA, and interdisciplinary scientist at the JWST Science Working Group. That is why JWST is so costly, because we've spent the last 2 decades building and testing every single piece a million different ways to make sure it doesn't have any flaws. But why must Webb be so complicated? Isn't a more straightforward mission just as effective? And why can't astronauts service it? The truth is that Webb never considered himself to be serviceable. The science it is supposed to deliver and the depths of space it is supposed to see cannot be performed with a spacecraft that astronauts can visit. The James Webb Space Telescope, affectionately known as the first light machine by astronomers, was developed to observe the earliest stars and galaxies that erupted from the dust and gas of the early universe, barely a few million years after the Big Bang. Since these stars and galaxies are so far, the visible light they emitted when the universe was only a few 100 million years old has moved into the near-infrared and infrared parts of the electromagnetic spectrum. Such unusual effect, known as the redshift in astronomical jargon, is caused by the universe's expansion and the resulting Doppler effect. It is the exact mechanism that distorts the frequency of a passing ambulance's car siren. Infrared radiation is effectively heat, and it may be detected using special sensors that are not the same as those used to see visible light. Because the stars and galaxies studied by JWST are so far away, the incoming signals are also incredibly feeble. The scientists and engineers behind JWST had to overcome several technological challenges to achieve the hoped-for finding. The James Webb Space Telescope will be approximately 1 million miles, or 1.5 million kilometers, distant from Earth. That's more than 4 times the distance between the Earth and the Moon. The telescope will orbit the Sun while making short circles around Lagrange Point 2, or L2, a point on the Sun-Earth axis constantly concealed from the Sun by the planet. At L2, the Sun's and Earth's gravitational pulls maintain the spacecraft aligned with the two large bodies. The James Webb Space Telescope may assist in addressing some of the most pressing riddles surrounding dark matter. Dark matter is indeed a mysterious, invisible kind of substance that is considered to account for around 27% of the known universe, outweighing visible matter by a factor of 6. Although accounting for a sizable portion of the cosmos, it has defied our comprehension since its discovery in 1933 by Fritz Zwicky, a Swiss-American astronomer. Dark matter has never been directly observed. Although the James Webb Space Telescope could not directly see dark matter, scientists believe that by studying the effects of dark matter on its surroundings, Webb will be able to answer several significant concerns concerning it. It would significantly increase our understanding of the cosmos as a whole. Scientists don't know what dark matter is made of, and they're still trying to figure out how to detect it directly. Scientists are now developing such technologies through tests at CERN's Large Hadron Collider, or LHC, the European Organization for Nuclear Research. Unlike previous studies, Webb will not detect dark matter directly, but examine its impacts on conventional, visible matter. Because you can't see dark matter, you have to take a circuitous route to examine it. But Webb has the potential to look at the dynamics of galaxies in new orthogonal ways to try to get at that. In a press briefing, Klaus Pontoppidan, a project scientist at the Space Telescope Science Institute, told Space.com, "Astronomers, for instance, can use pre-existing technologies to estimate how much mass is in stars and galaxies as a backdoor means of discovering dark matter. Many universes could not exist and move as they do without a massive amount of invisible material, which is one of the most compelling arguments for the existence of dark matter." Webb will take exceptionally crisp photographs in which researchers can identify disruptions induced by gravitational lensing, leading them to where the invisible mass is hidden to assist astronomers more precisely find that dark matter. Einstein's general theory of relativity describes gravitational lensing as a phenomenon. When a light beam passes through a vast mass, it is somewhat deflected because the mass slightly warps the fabric of space-time. Pontoppidan stated that scientists are still trying to figure out when the universe's early galaxies formed. The mechanisms involved in its formation are guided by dark matter evolution models, which impose different parameters on the initial galaxies at various times. Pontoppidan went on to say that Webb can be used to measure some of the basic properties of the universe's first galaxies, allowing us to comprehend their luminosity, mass distribution, and often more. If you liked today's video on James Webb Space Telescope will change the view of the universe, then you might want to watch our leaked Tesla phone Pi specs versus iPhone 13 Pro video on the left, or you might like our new Game Changer, Amazing IA Technologies That Will Change Our Life video on the right. Well, that's all we have today. If you enjoyed today's video, don't forget to like, share, and subscribe. Until we see you next time, ciao!